Assalamualaikum. Hi, for this video, we'll discuss about the rotational motion, continues from the simple harmonic motion that we discussed before. If you remember that, we introduced x as x equal to a cos omega t as a function of x. So what is relevant of the x equal to a cos omega t, because we want to find the oscillation of the pendulums and also mass spring system. Okay. So right now we will discuss a little bit about the rotational motion and the relation with the pendulums and also mass spring system. Okay, so we can choose either sine or cosine. Okay, both have correlated, they have just shifted by the pi over 2. So right now I'm using x equal to a sine omega t, which is a is the amplitude, this is amplitude. Okay, omega t, this will be the angle here, and also this term sine will be the what we call as a phase angle. Okay, so we discuss the phase angle later. So right now, example, sine graph. Okay, so the amplitude will be here. Okay, the maximum, and also this will be minus a, the maximum, the minimum. Okay, the minimum peak, and this will be the one cycle. Okay? And how is relate with the angle? Okay, right now, example for sine, it start from here, so the angle will be 0. Okay, change color, and then when you move to here, okay, 45 degrees, so it points something like here. And when we move to 90 degree here, so when this 90 degree, this will be 90 degree here. So 90 degree, the radian will be pi over 2. And we can move until here. Okay, start from 0 again. This will be the 180 degrees. 180 degrees is a pi. Okay, and we will move here 270 degrees here, 270 degrees. Okay, you can see here at this point peak, so it's a 3 pi over 2 radian. And the last one will be, we come back to the initial position, which is 2 pi, okay, which is equal to the 360 degree. So this how the equation of a sine and also cosine. For cos, the graph will start from here. This will be the top here. Okay, need to clean up everything here. Okay. For cos, okay, cosine okay, x equal to a. Okay, for this same to the sine, which is equals the phase angle will be 0. Okay, for cos, cosine we start with from here. Okay, so the graph will start here for 0 degree. This will be the 0 degree for the cos, and then move to the left for 90 degrees. So 90 degrees will be here, and then it move to the 180 degrees. This 180 degrees. Okay, 180 degrees is here, point here. Sorry, okay. So this will be the maximum minimum point, and then move to 270 degrees. 270 degrees is here, and the last one go back to the initial location will be here. So we will get the graph of cos. Okay, something like this. Not very nice graph, but something like this. Okay. Oh. So that will be the sine and cos. And you should know that this phase angle, when the phase angle is pi over 2, means that you can get here sine omega t plus pi over 2, which is 90 degrees, is equal to the cos omega t. Okay. So how? Okay, this will be a recap. For this, I like to have tables here. Okay, can put here tables. Okay. Okay, example. Okay, I think tables no. Okay. For sine, example, sine. Okay, we put this theta and sine theta plus pi over 2. Example, and how about cos theta? Okay, so for sine theta, okay, so example for theta here, if theta is equal to 0, so sine 0 is 0. Okay, and then for theta equal to pi over 2, okay, sine pi over 2, okay, remember this graph, pi over 2 is 1, okay, which is the maximum amplitude, which is A. I just put value of 1. And okay, we jump direct to the pi. For pi, sine pi will be 0, and 3 pi over 2, which is 270 degrees, will be minus 1. And for 0, sorry, for the 2 pi, so the sine theta will be 0. For okay, theta plus pi over 2. Okay, for theta plus pi over 2, example, for sine, so for theta 0, so means that you can get theta here 0, so become sine pi over 2. So sine pi over 2 is 1. And then for pi over 2, the theta is pi over 2. Pi over 2 plus pi over 2 become pi. So sine pi is 0. 3 pi over 2, 3 pi over 2 plus pi over 2 means that we become 4 pi over 2. Okay, 4 divided by 2 become 2 pi. So sine 2 pi will be minus 1. Okay, and then sorry. Yes, this. Sorry. Okay, sorry. Pi plus pi over 2. So become 2 pi over 2 pi. And then you can get 2 pi plus pi over 2. You can get 3 pi over 2. 3 pi over 2 is minus 1 here. For 3 pi over 2, theta 3 pi over 2 plus pi over 2, you can get 3 pi plus pi, 4 pi. 4 divided by 2, 2 pi. So sine 2 pi is 0, and it will continue to 1. Okay. So it shifted. Okay, for pi over 2. How about cos? For cos theta, for cos 0 is equal to 1. Okay, depend on this graph, remember. Pi over 2 for cos will be 0. Pi will be minus 1. 3 pi over 2 is 0, and 2 pi is 1. So you can see that this is similar. Okay, so that will be the relation between cosine and sine. Okay, right now we want to discuss about the pendulum and also the mass spin system, how it is related with the um, graph of sine and cos of the rotational. Okay, example with this pendulum. Okay, example with this pendulum. Okay, so this pendulum will oscillate. Okay, when we pull something starting from here, okay, so it will oscillate. So this will be the center point. Okay, this will be the initial point, maybe because we need to pull this before it will oscillate. So we can plot here, example, when they start from this point, they come here. When they reach the center point, it's here, and this will be time. Okay, so that we increase because this starting from 0. This is maybe a few seconds. We move here, and then going back, go to the maximum left. Become here, something like this, and then going back to the center, okay, and finally it will move to the initial. Okay, the starting point. So what we get here is cosine graph. Okay, so it will oscillate and we continue until the stop. Okay, so this will be the, that's why we can use x is equal to e cos omega t plus sine. Okay, and for the phase angle is equal to 0. Okay, since that we are using the cos, we can change this to the sine, a sine omega t, but plus pi over 2. This is similar, plus pi over 2, then it become this graph. Okay, so now we can go to the mesh spring system. For mesh spring system, actually it's similar. Okay, this will be the equilibrium. Okay, this will be the starting point. We need to pull the mesh. Okay, okay, this will be clear. And then the mesh spring will oscillate, go to the center here, then going back to the compress here. This will be the point here, and then going back to the center, and finally go to back the starting point. So it's something similar. So this will create the cosine graph. Okay, x equal to, this will be the a cos omega t. Okay, and the phase angle will be 0. So that will be the relation between the rotational, okay, cos omega t with the pendulum and the mesh system. So that's all for today. See you again for next video. Okay, bye.